Function composition. We are going to compose two functions. We're also going to find the domain of each. And to find the domain of the composition of functions, f composed with g of x. Remember, that's the same thing as f of g of x. We're going to find the domain of the inner function. And we're going to find the domain of the final simplified result. And then we're going to look at what they have in common. So this will make more sense once we actually have an example to try, but we're going to keep this in mind. So let's do an example. Consider the functions h of x equals 3 minus x divided by 2x plus 4, and j of x equals 7 over x. We are going to find h composed with j of x. Well, we can rewrite that as h of j of x. Remember, this is h composed with j with an input of x. This does not mean multiplication. So we're going to replace j of x with 7 over x, its function. Put that right here. So this is h of 7 over x. Okay. Every time we see an x for h of x, notice this h of x is now h of 7 over x. We've replaced this x with 7 over x. So we're going to do the same thing here and here. And I'm going to remind you of an easy way to do this if this is hard for you. So let's do it over here. We're going to do some scratch. You may not need to do this. If not, that just skip past this. But let's do h of 2. Well, that's 3 minus 2 over 2 times 2 plus 4. So what I'm doing is just practicing, trying to get the feel for how to plug in, how to replace an x with something else. Most of my students can do this very well when it's just a number. So we're going to play with some numbers till we're comfortable. H of 10 is 3 minus 10 over 2 times 10 plus 4. H of 0.7 is 3 minus 0.7 over 2 times 0.7 plus 4. I'm just pulling these out of the air. These have nothing to do with the problem. This is just so you can sort of get a feel for how to do this. H of 94 is 3 minus 94 over 2 times 94 plus 4. All we're doing is we're changing whatever I put in as my input. Remember, this part right here is my input in place of every x in here. Let's do another one. So what's h of 7 over x? Well, that's 3 minus 7 over x over 2 times 7 over x plus 4. And most of my students, when I do this, are actually kind of in shock. They try to do it directly, they can't. But after we do a few numbers, then they kind of get lulled into complacency and they turn off the part of their brain that really is actively thinking about it, and they shift to autopilot. And then they're able to actually do the process. So h of 7 over x is going to be this. 3 minus 7 over x over 2 times 7 over x plus 4. So we need to clean this up. We want one simplified fraction. This is what we call a complex fraction. So there's several ways to do this. Most students feel more comfortable with building a common denominator. So you could put each of these over 1 if you wanted to. I'll show you the other way in a second. So you build a common denominator of the numerators. So you have 3, it's over 1 minus 7 over x. So this bottom needs an x, but if you put 1 on bottom, you put it on top, because you're only allowed to multiply an expression by the number 1, right? X divided by x is 1. We do the same thing on the bottom. Now on the bottom, notice I have 2 times 7 and 1 times x. When you're multiplying fractions, you do top times top, bottom times bottom. So that simplifies to 14 over x plus 4 over 1. I need a common denominator with the fractions in the denominator. So these guys need a common denominator. This is a 1 and this is an x. If I multiply this bottom by x, then I have the denominator I need. But if I multiply this bottom by x, I better multiply the top by x. That way I'm multiplying by the number 1. And then you clean it up. This is 3x over x minus 7 over x, and you have 14 over x plus 4x over x. Common denominator of the numerator is x, so I rewrite the common denominator and combine the numerators. Same thing on the bottom. Common denominator is x, I combine the numerators. Now, if you have a fraction divided by a fraction, there are 3 steps. A lot of my students say multiply by the reciprocal, but you need to be careful. You need to know which piece has the reciprocal, which part you're looking at. So here's the top fraction, here's the bottom fraction. So we are going to rewrite the fraction in the numerator. That's the first step. So put an equal sign and rewrite the fraction in the numerator. 3x minus 7 over x. Now we're going to multiply by the reciprocal of the fraction in the denominator. So that's times x over 14 plus 4x. Now you can see we have an x on top and an x on the bottom, so they're going to cancel. And we're going to be left with a single fraction. That was our scratch. We're left with 3x minus 7 over 14 plus 4x. This is h composed with j of x. I'll show you one thing real quick before we continue. There was an easier way to simplify this. You could have done 3 over 1 minus 7 over x over 14 over x plus 4 over 1. You could have multiplied the whole thing by the number 1. Remember, when we multiply by the number 1, that means it's the same thing on top and on bottom. So you could multiply by x over 1 over x over 1. Do you see that's this and this are the same? So you're multiplying by the number 1. And then distribute. Okay, so x times each of these, x times each of these. When you clean it up, you get 3x, because that's this times this, that's 3x. You see that? 3x over 1, but I can write that as 3x. And then you multiply these together. Well, there's an x on top and an x on bottom, right? Negative 7 over x times x over 1. See the x's cancel? So 3x minus 7. Do the same thing with the bottom, right? You have 14 over x times x over 1. The x's cancel. You get 14 plus 4x. This is a little bit shorter, but you have to make sure you're comfortable with this. Okay, so let's actually find the domain. I told you there's 2 places to check. First place to check is the inner function. Second place to check is the final simplified answer. So for the domain, piece 1, we have 7 over x. Well, we know the domain of a rational function is where the denominator is not 0, right? So x cannot be 0. If you divide by 0, that's what killed the dinosaurs. So that's how we find the domain of the inner piece. Then we look at the final simplified answer, 3x minus 7 over 14 plus 4x. Same as the top. Denominator can't be 0. Denominator can't be 0. Our denominator is 14 plus 4x. It cannot be 0. Now we're going to solve for x. So we get 4x cannot be negative 14. You see we subtracted 14 from both sides here. Now we want the coefficient of x to be 1, so we're going to divide both sides by 4. So x cannot be negative 14 over 4, which we can reduce that, right? Divide both by 2, get negative 7/2. So we see that x cannot be 0 and x cannot be negative 7/2. So, looking at the top piece, x cannot be 0. We have an open circle and we can shade all of this. This is x cannot be 0. Then we're looking at x cannot be negative 7/2. So we're going to put negative 7/2 on our number line as well. Open circle there. So that's like a picture of the number lines that we're allowed to use, but we need to have both of them be true. So what pieces are we allowed to keep? Well, we're allowed to keep this side. So that's negative infinity to negative 7/2. Negative infinity gets a parentheses because it's not a number, right? It's a concept. But notice negative 7/2 only gets a bracket if it's in both places. Well, negative 7/2 is included up here. I didn't label it, but this is negative 7/2. It's included up here, but it's not included here. It has to be included in both, so it gets a parentheses. Union. Well, we see that this middle section is also in both. So between negative 7/2 and 0, notice again, negative 7/2 cannot be included. So parentheses. And then 0 is not included in the top one. So we have to throw out 0, union. In this section, 0 to infinity, again, we're still throwing out 0. So this is the domain of our composition. Okay, let's try this again. Let's do another composition, same functions. H of x is 3 minus x over 2x plus 4, and j of x is 7 over x. So now we're going to do j composed with j of x. We can rewrite that as j of x, or j of 7 over x. We're replacing the input of j of x with 7 over x, which means this x right here is going to be replaced with 7 over x. If you need to, do the scratch work we did earlier, plugging in, like j of 4, that's 7 over 4. J of 19, that's 7 over 19. J of 53 is 7 over 53. So j of 7 over x is 7 over x. This is the piece I'm replacing, right? This says 7 over x. Well, down here I have 7 over a new x, right? Okay, then we clean it up. So we have a fraction divided by a fraction. We had 2 steps, right? First step was rewrite the numerator. So that equals 7. I'm going to put it 7 over 1. And then we multiply by the reciprocal of our denominator. So instead of 7 over x, I'm going to multiply by x over 7. We notice that the 7's cancel, right? So our answer is x. So j composed with j, if the input is x, the output is x. So if you remember from inverses, j of x is its own inverse. If you haven't done inverses yet, that'll be a little spoiler alert. Let's find the domain. Remember, we check 2 places. First place we check is the inside function. So we check here, the domain of 7 over x. We make sure our denominator is not 0, so x can't be 0. Then we check the final simplified answer. So x. Well, the domain of x is all real numbers, right? There's no domain issues. So you may be tempted to look at this right here and say, wow, j composed with j of x is x. Domain's all real numbers. But you have to be careful, because inside this calculation, when we actually did this, we had a fraction with x on the bottom. So at this point right here, before you simplify, I think it's easy to see there's a domain issue. But then it'll cancel if you clean up, so you might not see it after that. So we still have to keep these in mind. We have to throw out both of them. So you have 0 is thrown out, right? And this one is the whole number line. So the domain of j composed with j of x, we have to throw out the number that's thrown out of any of the pieces. So the domain of j composed with j of x is negative infinity to 0, union 0 to infinity. Because I'm throwing out x equals 0. Okay.